Okay, so for anyone who has one of these vacuum cleaners, I've had mine I think for 3 to 4 years now. Essentially, the battery is dying, and that can either be a balancing issue because it's a lithium battery pack, or I'm just going to replace the batteries. If I get ambitious, I'll potentially 3D print a slot so you can actually just pop on batteries, similar to like these Ryobis or Milwaukees or whatever. But I think for now I just want to get this working. So we're gonna go ahead and take this cover off the back side. So that's off. The nice thing about this vacuum cleaner specifically, this entire battery pack literally unclicks and you can actually remove the entire thing. And as you can see, yeah, I'll count the cells in a little bit, but there's most likely just 18650s in here, and we'll test them and balance them and go from there. And as we can see, we have 18650s here. These are most likely going to be spot welded together like all the other lithium battery packs in the world. I'll try to keep these protective covers so I can reinstall them. So yeah, they are spot welded together. It's possible that this just could be unbalanced, but chances are the cells are just degraded at this point. So, I mean, obviously there's a BMS in here, which we can see if I pull this off. This is your battery monitoring system. This keeps the cells balanced, at least hopefully it has balancing. But sometimes these chips will throw a flag if one of the batteries completely disconnects, which would require custom programming to reset it. So hopefully that's not the case, but I'll have to see. So I'm gonna move that over. We're just gonna run some basic tests here. This is the positive side, and that's most likely negative. So if we test that, so it's 22 volts, which is within the range of the battery. Chances are what's happening is one of them is sagging significantly when you actually turn it on, which is basically throwing this thing in protection mode. That's 3 or 2.95, 11, 4, 8, 7.5. Yeah, so what I'm going to do to be safe is actually just pull all of these batteries and then go from there. So it looks like we got to take these screws out and potentially unsolder the leads that go to these tabs. So yeah, let's get started with that. So I've actually opted to just peel up the tabs and then remove the whole board at once, because these are generally possibly going to be damaged. I'll see if I can reuse them and re-spot weld them without changing them, because they're already bent to the perfect size for all these cells. So you want to be careful when you do this. Like as an example, see if I can get a close up here. Maybe closer. Extra close. So you can see I peeled that one up already. Generally what I do, you want to take a sharp tool of some kind. You want to be very careful with this because let me see if I can get another cell without a protective coating on it. So this is an 18650 without the heat shrink on it. Where people go wrong and fires happen, this is the positive side. This is negative. So if you sit here and you try to pry this off and you're wedging on it like that and you touch positive and negative here and here, you're shorting the battery out and it's basically going to explode on you. Now, see if I can find one. Anyway, well, these batteries have protectors on them too, but yeah, like there's kind of this ring that goes under the heat shrink, similar to that. You can see it here, it's the plastic nylon one. And so that'll help prevent shorting positive to negative, but still you want to be careful when you're, pulling on it. So try to do the same on this one. So I basically just get it started like that, and then similar to like a tin can, I grab it and roll it off. I actually want to test the voltage again now that we have them individually. .9, 4, 3.8, 3.4, 4. So yeah, basically 3 trash batteries is what we have. I'm gonna capacity test them and everything, but yeah, definitely want to swap these out. The reason this is also sketchy is because like these can literally catch fire and burn your house down if they're not maintained. What I'm going to try to do, use a flat head here, turn it. It has these tabs here that are very tight. There we go. It's one end. This other one needs to pop. There we go. Then the the cells will separate. Some people like to sand these off. I like to break them off as cleanly as I can. Sometimes you'll get points sticking out the bottom. Basically, what I'm doing there is I'm just taking like this miniature vise and I just tap it a little bit to kind of flatten them out. It won't matter too much if they get reused. I can tell by the weight of these that they're probably not very good. Yeah, they're 2 amp hour, so they're EVE cells, which again are not super great. Like the Samsung cells are better. But I have a lot of salvaged ones from other battery packs, like these Ryobis, and there's also some Milwaukee ones. But yeah. So I'm gonna take some of these cells, and the ones that were low voltage are probably bad. So what I'll do is pop one on really quick. I should probably use the tripod. That would be the smart thing to do. If the voltage isn't around 4 to begin with, like that's 2.94. 3.85, 3.48, 3.99. So this first one's probably trash, so I'm actually just gonna take it out and not even bother for now, because I have 6, so I want to test the potentially good ones. So that's 3.99. Potentially this one might be bad as well. Let's test it. Okay, so these are like the highest voltage ones out of here. I'm gonna go ahead and put it on capacity or normal test. I'm gonna leave it at 500 milliamps. Actually, let's do 1000. We're gonna put this one to normal test, 1000 milliamps. Normal test, 1000. Normal test, 1000. And we're gonna leave these, and they're gonna fully charge, and you didn't see anything I did because it's not on screen. But basically, 1, 2, 3, 4, they're set to normal test and 1000 milliamps. So it's going to fully charge them and then discharge them and test the capacity, and then it's going to charge them again. But pretty sure these two are bad. I think this one might also be potentially damaged, but we'll see. So I got the batteries on the balance tester. I took a lot of those batteries from various tool packs like the Ryobis and Milwaukees, and I actually put them inside of this portable battery bank. Not the best thing to do because they're obviously made for high current applications, not storage. So they're all in parallel here, so I like to just keep them in this thing for the sake of them naturally balancing. But yeah, I'm gonna go ahead and open it up and then see what we got in here so I can use 6 of them. And on most of these, I already wrote their potential voltages and whatnot when I first checked them, because the cells were sitting for a long time anyway, so this just kind of just helps me determine if they were garbage or not. So these are INR 18650 20Rs. These are what you find in like Milwaukee or DeWalt battery packs. So like this would be okay to use for this application. So what I write on these, because I did capacity test them, this is 1955 milliamp hours. The internal resistance when I tested it, 37 mega ohms, I think, 4.099 volts, and like this one's 4.096 volts. So like these are fine. But yeah, let me find 6 that are good. So if I wanted to expand the capacity of this, so we have, how many do we have? We had, this was my original crappy schematic, but essentially here was just one tab. These two would be connected together with a tab. These two are connected. So if I want to expand the capacity on each one of these banks, I can add another one in parallel. So let me see if I have enough batteries to actually do that. Granted, I don't think I have the space for it without, like, my plan is to 3D scan this and make a larger expansion chamber for it. Because that's what the board reinserted. So I'm not sure. Let me make the regular stack and then I'll test the space again. So this is the correct orientation. Basically we have positive, negative, positive, negative, positive, negative. So we have main positive here, main negative here. I don't like how these surfaces are, so I'm gonna try to clean these up a little bit before I fully snap it together. So now that we have the new cells in here, we can theoretically start spotting the tablets or the tabs on it, but and also they rotate, so if you need to change the orientation, we can do that. But what I need to prep now is the actual board itself, because this has the old tabs still stuck to it. So I want to take those off. So all the holes for the tabs are now fully passed through. So this is ready to essentially go on top of the battery pack. I have to remember to put the temperature probe through the holes correctly. Aligning that is kind of annoying, but I did get it just now. So I think for the new tabs, because the old tab setup, they ran underneath and then out, but I think I can run them through the top. You guys don't have a spot welder. So originally when I bought one of these, I thought it was garbage, but they actually work fairly well. You can set your pulse width and a bunch of different things. I think I already have this tuned in to 0.2. Let's see. So this is good to go now. Not the prettiest thing, but it works. And again, I'll potentially 3D scan this and make a larger version, or I'll just simply take this and then make a slot on it so you can just pop on drill batteries and whatnot, like tool batteries directly on here. You could use Milwaukee's or DeWalt's or whatever. But yeah, I'm gonna seal this back up. And then I can start cleaning again. Yay. Well, this is fireproof and thermal insulating tape, so this is good for a lot of applications, but especially lithium batteries. Luckily the BMS didn't have any flags that it throws, like the DJI batteries are pretty bad about that. You can't just swap the cells out without getting a programmer and locking it in and doing a bunch of other stuff. And then should be good to go. Give it a quick run again. And she works. How long? I'm not sure, but they're better quality batteries than the EV batteries that were on there. All right, gotta clean up now, but that's how you fix the battery on one of these. Take care.